Good day, ma'am. Good day, everyone. Well, our topic for this week math is all about generating function. So, do you know all about generating function? Well, generating function are important for solving different equations. The generating function arise in two different manners. One as counting device, and the second is the investigation of recurrent solution. So, let us concentrate first on generating function of various series. The generating function for the sequence A0, A1, and A key of the real numbers is an infinite series. Capital G of x, the sum of A0 plus A1 and so on, plus A key to the end. The sum of key goes to 0 up to infinite of A key to the end. The sequence of A key with A key sum 3, then ang generating function is, ang iyang kabuta nga di is 3, count ka mo 3, and then sa number 2 isabi is, ang iyang sequence is A key sum of key plus 1, then ang iyang kabutang sa generating, then ang iyang generating function is key plus 1. Ikanito ka ba siya sa ikatulo na one guide example? Generating function for finite sequences. Generating function for finite sequences of real numbers can be defined by extending a finite sequence of A0 and A1 and A sub n into an infinite sequence by setting A sub n plus 1, the sum of 0, and A sub n plus 2 equal sum of 0, and so on. The generating function of capital G of x of this infinite sequence of A sub n is a polynomial of degree n because no terms of the form A sub g x g with g greater than n. So we have here example, capital of x, the sum of A0 plus A1 plus A2 and 2 squared and so on. Well, let's see the solution of this. Capital G of x, the sum of 1 plus x plus 2 squared plus 3 squared and 4 squared and so on. Maybe we're right here, sum of key goes to 0 and infinite of A key to the end. And sum of 1 over 1 minus A. So as you can see, including of this information is really going to small package like this, 1 over 1 minus A. So we have an example, what is generating function for the sequence of 1, 1, 1 and so on. So the generating function of 1 and 1 and 1 is 1 plus x plus 2 squared plus 3 squared and 4 squared and so on. So consequently of this sequence 1 on 1, so nakita niyo na ang generating function niya is capital G of x, the sum of 6 squared minus 1 and x minus 1. So ang generating function. Well, let's proceed about counting problems and generating function. Example, find number of solutions of A1 plus A2 plus A3 equals 17, where A1, A2, and A3 are non-negative integer with this solution. Example. So, solution, the number of solution is the coefficient of 17x squared and the expression of 2 squared plus 3 squared plus 4 squared plus 5 squared and so on. So as you can see guys, kining na this example is kaning A1 and plus A2 and plus A3 is, this is a product. So tulo ka buok product, and then the coefficient is 17. Well, kabantay ka mo sa mga solution is 3 siya ka buok kuan, and then open parenthesis. So parenthesis. Tulo siya kabuok diri kay kuan man siya kanang dapat 3 products, so dapat ang makaputang sa mga dito kabuok. And then this follows because a term equal to is obtained in a product by picking a term in the first sum A1 squared, a term in the second sum is A2 squared, and the term in the third sum is 3A squared, where A1 plus A2 plus A3 equals 17. So there are 3 solutions since the coefficient of 17x squared in the product is 3. Example, use generating function to find the number of a key combination for a set with n elements. Solution. Which of the n elements in the set contributes with the terms 1 plus x to the generating function? Capital F of x, sum of a key goes to 0 up to n a key to the n. Hence of capital F of x equals 1 plus x sub n, where is the generating function for a key, where a key represents the number of key combinations and of the set with n elements. By the binomial theorem, we have capital F of x, sum of key goes to 0 up to n a key to the n. So here we have example of counting the problems of generating function. Example, suppose we want to count the number of ways to choose 3 objects from a set of 5 objects. The generating function for this problem is 1 plus x less than 5. The coefficient of x less than 3 and this generating function is c. 5 and 3 equals 5 over 3 plus 2 equals 10.